Let's bring up on the screen more about how far is it that we can take our IT infrastructure integrating AI-driven future-ready data centers. May I welcome Mr. Raghuveer Singh, Senior Director, Colo Cloud Thermal Solution at Vertiv India. A round of applause as he joins us on stage, please. I thought we'd had a lot of energy. Let's hear it up for him. Thank you.
So, very good afternoon and welcome once again after lunch. So, Madam has already done a fantastic job to make everyone awake. I will try instead of hi, AI, AI. I think, you know, everyone is hearing this word and it is market buzz now. All of us, not only this forum, but all the forum, the new, everywhere all across the country, this is what we hear the most. So, how Vertiv can help you to build or to convert your existing and new infrastructure AI ready. That is what I'm going to talk about. And I'm sure that, you know, this will be a helpful session for next 10 minutes, 12 minutes, we'll dive deep into this segment. Everyone is talking about AI. So how AI is impacting us and how it matters to us. AI is here. We cannot go anywhere from AI. And it is converting our life into a different segment altogether, be it business, be it our day-to-day activities. Everything is impacted by AI. So what we can do to transform your infrastructure is what you will see in the next slides. And how and why we cannot go away from AI. You look at the slide here that this market is huge. There is a lot of opportunity which we see that close to 5% of the IT infrastructure, IT side, is going to get the AI opportunity by 2027, and which will be 12%, which is close to $1.3 trillion of business opportunity. So can we really ignore this? Not at all. This is huge, really. And it is going to come. It is going to come, and it is going to come to our infrastructure, to our businesses. So what impact it is bringing? Is it coming just along the way it is right now? The servers, the chips, the GPUs, what you see right now, is it going to be same? Not like that. There is a growing infrastructure. There is a change in the GPU thermal design power. The earlier older design powers used to be close to 200 to 300 on the GPU side, and CPU was just 60 to 70 or 80, close to that. But now the CPUs, the new CPUs are also 250 plus, and the GPUs are already 1200. You look at the Blackwell series, which is launched by NVIDIA, is 1200 thermal design power. So that defines the growing densities of the GPU side. Imagine such GPUs are packed in every server, and the rack is filled with such servers. The densities are going higher and higher. Close to 80% of it is right now below 20 kilowatt, but soon most of the IT servers, this is a survey of Uptime Institute, which says that more than 80% of the IT managers believes that the densities are growing, and the density will go beyond that. It's no more going to remain below 20 kilowatt. Vertiv is working closely with Intel or likes of like NVIDIA. We are a partner for NVIDIA, advisor on the board with NVIDIA especially on the network, partner network. So what we are doing with NVIDIA? Look at this slide here. There is a cooler chip program. So Vertiv is investing a huge money into this in a new liquid cooling technology which is being explored for the upcoming, not for the current densities what we have on board, but for the future what is likely to come up. The densities which will go beyond 200 kilowatt or 350 kilowatt or rack, and the densities which may reach to 500 kilowatt or rack. So how you are going to cool it? So this is a cooler chip program where you see that the technologies are being combined together. Immersion cooling and direct to chip cooling, two technologies being combined together. Vertiv is working closely with the companies like Boyd, NVIDIA, and some of the US universities, research institutes to see that how we can explore the new cooling solutions for that. So what is being used right now is, as I mentioned, that most of the densities are below 20 kilowatt right now, which are typically being cooled by the perimeter systems. Those who are familiar with the perimeter system means, imagine you have this as a data hall or a server, bigger data hall, and you have cooling systems which are typically air-cooled type, and it is pumping the cold air under the floor or inside the data hall. So that's how the perimeter system approach works, with or without containments. Imagine the density is going up, you can deploy row coolers or you can declare rear door heat exchangers. As the densities goes further up, the limitation of the air cooling comes in. You cannot cool beyond a certain point because air has a limitation on the removal of heat from the servers. So there the liquid cooling comes in picture, especially beyond 20, 30, 40 kilowatt or rack. Then there the liquid play a major role. So what is that, the big role which Vertiv is playing along with NVIDIA, you will hear here. Can you please play this video? Yeah.
From general purpose to accelerated and AI computing. Compute density and therefore power density are increasing incredibly. Every aspect, from computing, networking, and software, are all groundbreaking computer science. The data center infrastructure is also incredibly complex. The most advanced cooling and power technologies are essential. Vertiv is the world leader. We've enjoyed a great partnership with Vertiv for many years, and our collaboration is growing in leaps and bounds as every industry and region invest in building AI factories at enormous scales. Our partnership with Vertiv is more important than ever. I want to congratulate Giordano and Vertiv on an extraordinary year. This is just the beginning of great things to come as we partner to put AI in the reach of every company and industry.
Yeah, so you heard NVIDIA co-owner talking about how Vertiv is helping industry to deploy AI. So this is the NVIDIA GTC launch in 2024 March. You can see here the CDUs this is the CDU which is placed here, and the liquid cooling racks which are placed along. So what kind of CDUs are required for liquid cooling? So this is the direct to chip cooling kind of approach, where we have on the left side you can see this is a floor mount CDU which is for direct to chip application up to 1350 kilowatt. And then the middle one is a rack-based CDU, and the right side is the air-based liquid-to-air CDU. So wherever you do not have a primary side of system, you can deploy such things to deploy a liquid cooling racks. This is immersion cooling technology which Vertiv has up to 200 kilowatt of rack density. So in various configuration again, we have done multiple projects across India now. At least 5 to 6 projects we have deployed in India. So it's no more something which is being just talked about. It is already being deployed. So how does it work? You can see on the right side here, this is let's say a rack where you have an inlet and outlet pipe which will be connected to your rack there, and the heat comes back here to the CDU, and inside a CDU there is a heat exchanger to exchange the heat with this is called as a secondary circuit, and this is a primary circuit. So this heat is picked by a primary circuit to reject in the chiller or in a dry cooler or adiabatic dry cooler or a cooling tower. And in between there is a possibility to explore this heat by using heat pumps or different application for hotels or for housing or different application. So you can use this waste heat for minimizing the carbon footprint. So is only the cooling a challenge for AI? Power management is equally a challenge. How do you distribute power? When we talk about 250 or 300 kilowatt of rack density, is power easy to distribute? Really not. It's one of the difficult way to do. Your PDUs, typical PDUs which are available now, will no more be applicable when your rack density goes beyond 100 kilowatt. So your bus bar sockets, bus bar tap-off boxes, all of that changes. So we have to also look at on power distribution side. And along with that, we have to also understand that AI is also creating a spike, which is in milliseconds. So we have to handle that spike. So your UPS system, the other power distributions on the upstream needs to be designed for that. So when you deploy AI racks like GB200 or GB100, those are like, close to 4 million USD kind of a rack which you bring to your facility. Imagine you have such hundreds of racks, a kind of amount of money which you spend. So for such kind of an infrastructure, you should have a skilled manpower to do that. We have to have a skilled manpower on deploying the liquid cooling side of it and hybrid cooling approach of the fan walls or rear door heat exchanger which will be required for that. And you see here, that your power distribution is also like the PDUs or the power distribution side of it needs to be also designed properly. So this is a typical layout of an existing site, like how you can convert to direct to chip by utilizing direct to chip with the in-row for deploying the 50 kilowatt rack. Suppose you have hundreds of servers placed in one data hall, and some of the racks you want to deploy with liquid cooling. So you can deploy with direct-to-chip cooling CDU, and by deploying in-row or rear-door heat exchanger, you can convert that infrastructure for AI ready. If you do not have primary site system, which can work on deploying this system, then what you has a liquid to air kind of a CDU where you do not require a chiller or a cooling tower itself. So you can just place it along with the racks of your liquid cooling and you can deploy this technology. This is very important, especially for the existing brownfield or retrofit kind of projects where you want to deploy AI racks, but you do not have a existing infrastructure of chillers or something to deploy, or you have limitation of deploying such kind of services in the existing building. So these kind of cooling technologies are also there which can support this. The another one is a big project, like you have a greenfield project coming up for like 100 megawatt campus or 200 megawatt kind of a campus. So there the approach can be completely different. So we can have like 130 kilowatt kind of a rack density being cooled with the direct to chip cooling. I'm already working on 5 to 6 projects for India where the rack densities are ranging from 85 kilowatt to 132 kilowatt a rack. So it's no more, like I mentioned, it's not just a talk. It's really something which is going to be deployed by next year, Q1 or Q2, we will see big deployment of such kind of densities happening in India, especially for the hyperscalers. And what Vertiv has to offer you, right from smaller density to the bigger ones. So for the smaller rooms, we have room cooling kind of approach where you have perimeter kind of system. Vertiv is a global leader in thermal management. And then for the larger systems, we do have like chillers or fan walls or these kind of systems available, including UPS, PDUs, bus bars, and monitoring solutions. These are some of the projects which we have deployed for rear door heat exchangers or immersion cooling or direct-to-chip cooling. We have achieved close to 1.25 PUE. So PUE is one of the most criteria when you deploy liquid cooling. You can reduce the power consumption drastically. So Vertiv has a local presence, close to 40 branches across India. Whatever we develop, like most of the products we develop locally, and we do service also locally. So the key message, this is my last slide, and the key message for this is, when you have to deploy such kind of a costly infrastructure in your existing or new buildings, it definitely requires experienced partner. It's not just, like you bring CDU from someone, pipes from someone, chiller from someone. You may have to look at somebody who has experience of deploying all of this and can also service and maintain this. So Vertiv has that kind of expertise already, not only just in India, across the globe. And we can do end-to-end integration of all these services, and we have already experience of executing such large projects of liquid cooling or AI-based, and we have strong service networks, and Vertiv is known for that. So that's it. This is my last slide. Thank you. Any questions?